right, Nate, what do you say? Even odd or neither?
I'm going with odd.
All right, we got one odd. All right, Kayla, what do you say? You say neither. All right, Serenity.
I'm gonna say neither.
We got neither. 2-1, neither.
I said neither.
3-1, neither.
I said neither.
Neither. All right, it's odd.
Yeah.
Now let's go through why. Go through why. Now, just before we get to this, just a little bit here. Like if you have -1/2, make sure you understand it. That would be the same as -1/2, correct? That would be the same as 1/2, correct? It would not be. You can't do that. Like so what I mean by that is you can't have like -x over, I don't know, x plus 5 and make it -x over -x plus 5. That's just wrong, right? Because the negative can either go to the top or it can go to the bottom, but it can't go to both. Okay. All right, so now let's take a look. Here, when you plug in, you have to evaluate f of -x. And so it's -x to the 4th plus 6 over 4 -x cubed minus 3 times -x. Okay. And so, well, that just simplify each term. And so this becomes x to the 4th plus 6. This becomes a -4x cubed plus 3x. Well, is it even? Well, it's not the same thing. Okay, so it's not even. So, but we got to take a little bit closer look at the denominator. And if I factor out a negative, okay, and I put that right there, and it becomes -4x cubed minus 3x. Well, that's the original, right? With a negative in front. So this would just be like 1/-2, where I can take that negative in the denominator and just put it out in front of the whole thing. Okay, so this is why it's going to be odd, because I got your original over a negative, so you can make that negative x to the 4th plus 6 over 4x cubed minus 3x, like that. So therefore it's odd. Like I said, this is not, I don't know, it's not obvious the first few times you go over even and odd, okay, and evaluating it this way. Questions though? Does that make sense in these? I mean, this helps me explain it, but this is the actual problem. All right. Everybody did good except for a couple here. I won't name any names. I'm 77, 78. But, you know, check your answers. Check your answers.
Why not? It was like a little, like I didn't Sept playing, and then she's gonna go.
All right, what's the answer for 77? 4x plus 2h plus 3, we agree?
Yeah.
Okay, 4x plus 2h plus 3.
Does it have to be in like that particular order?
No, it doesn't have to be in that order, just as long as the, I don't know, as long as the signs are right. It doesn't have to be in that order. Anything else? Anything you need to touch on? We got one more section, 2.6, before quiz. We'll review a little bit tomorrow. With some linear functions and piecewise. I gave you a couple handouts here. This is called a library of functions. That top, or the second one I gave you has like 9 graphs on it there. It says library of basic functions. These are things I think you all have seen at some point, and you know most of them, probably committed to memory. But we're going to list the key factors. So here's what I want you to do. We're going to take about, 7-8 minutes. I want you to turn in your book to page 257 and 258. And basically, you're going to fill in that sheet. You're going to fill in that sheet. The last 3 in the book, we're not going to formally list, but if you see that you're just going to do a quick graph and then list domain and range, where it's increasing or decreasing or constant, and then the type of function and symmetry. So is it even or odd? And then therefore, what does it lead to in terms of symmetry? Okay, so like I said, take 6-7 minutes, and then just fill that in. -4 minus 6 over -3 minus 2, -10 over -5, looks like +2. Now pick either point. And now what I would do is by having 2 negatives versus 2 positives, I'm always going to pick the positive. So I'm going to do y minus 6 equals 2 times x minus 2. Go ahead and distribute and solve. Add 6. Add 6. I get y equals 2x plus 2. All right, now the only thing it does is find the function. So do write it in function notation, which means at the end, all you got to do is take that y out. Make it 2x plus 2, okay? All right, so we've done the concept. Now I'm just giving you ordered pairs or function notation. All right, piecewise functions. All right, we're going to deal with functions where, like, for certain values, you use one equation. For other values, you use a separate equation. Okay, we have to graph those together on one axis. It's called piecewise functions. That first one you have down there. All right. First of all, make sure this makes sense. Looking at that function, what is f of -3? What's f of 0? And what's f of 5? Using that function, what would those be? You just kind of answer those yourself. All right, so f of -3. What's that going to equal? Aaron, what do you think? Not sure? Oh, Peyton, help out.
I don't know.
Mackenzie, help her out.
I don't know.
Maybe.
2 for the -3.
2. All right, now, for any, that's 2's probably throwing you off. For any number less than 0, when you plug it in, what's the answer you get back? 2. Okay, so what's f of -5? 2. What's f of -10? 2. All right. What's f of 0? Well, it's x, but what's my x? 0. What's f of 5?
0.
Who said 0? Not 0. It's 5. So you plug it, for any number less than 0, you plug it in here. But now that's just f of x equals 2. This is f of x equals x, so what do you get back whatever you plug in for anything greater than or equal to 0. All right, what's the graph going to look like? Just shake off some cobwebs here. All right, if x is less than 0, it's just the function f of x equals 2. Okay? Which is what that's your constant function, so it looks like a horizontal line. But that's only for numbers less than 0. All right, you've got to be careful here. We got to go right up to 0, but not include 0. Which means I got to use like -0.1, -0.01. So what you do is you actually started at 0, but you put an open circle there. And then we draw a horizontal line to the left. Okay? What's the next piece look like? What's the next piece look like? It is for anything bigger than or equal to 0. X is greater than or equal to 0. We use the function f of x equals x. And then, which is our identity function. So plug in 0, you get back 0. Plug in 1, we get back 1. Plug in 2, you get back 2. It's going to look like that. Okay? So one's a horizontal line going to the left. The other one is your identity function going up. All right, for that next one there. Okay, copy down those equations. I know they're not on your paper. All right, before I graph it, I want to make sure we understand how to substitute in. And I didn't do a great job on that last one. You got 2 equations that we're dealing with. F of x equals x squared and f of x equals -x plus 2. And based upon where the number is based upon which equation you use. So any number less than 2, we plug into x squared. Any number bigger than or equal to 2, we plug into the second one. All right, so what's f of -3? Okay.
9.
It's going to be 9. It's going to be -3 squared. It's going to be 9. What's f of 0? Okay, Emily, what do we bet?
0.
0, because it's going to be 0 squared. What's f of 2? Luke, what do you think?
0.
It's going to be 0 because we plug it into this equation here. -2 plus 2 is 0. And what's f of 5, Ryan?
-3.
-3. All right, I feel nice. All right, now let's graph it. I'm gonna graph it in 2 pieces. I'm gonna say if x is less than 2, I'm gonna use the function f of x equals x squared. Now, unless I absolutely know what it looks like, I'm gonna do just a little mini chart. Okay, unless I absolutely know what it looks like, I'm gonna do a little mini chart. And so for this chart, I know it says x is less than 2, but you still want to plug that in because that tells you where to start it. Okay, don't start it at 1. Start it at 2. And I want to pick some numbers that are less than 2. I'm going to pick 1, 0, 1, and 2. You may not need that many. Just depends upon the equation. All right, when you plug in 2, you get back 4. When I plug in 1, I get back 1, 0, 0. That should be a -1 and a -2. And then I get 2 and 4. it's a parabola. So the key thing here is you started at 2, 4. You have to start it there, but we have to put what type of, you have to put a open dot. So go to 2, 4, put an open dot. Now the other ones are just regular points, and this continues everything less than 2. So it'll look like that. But it has to start at 2, 4 and essentially stop there. Now you go to the next piece of the equation where x is greater than or equal to 2. I'm going to use f of x equals negative x plus 2. Well, unless you absolutely know what it looks like, I'm going to plot a couple points. It's linear, it's got to be a straight line. Negative, so I'm going to start at 2, and I'm going to pick numbers bigger than it, 2, 3, and 4. Negative 2 plus 2 is 0. Negative 1, negative 2. So this one will have a closed dot there because it includes that point at 2, 0, 3, negative 1, 4, negative 2. And there you go. All right, so you're going to have those two separate pieces. There is, and they're going to be, you're going to come up to one, and then the other one's going to start somewhere else. Okay, they shouldn't like overlap left and right. They might hit the same numbers vertically, but not left and right. All right, flip it over. And let's see. You might want to, and I'm going to do this here. I'm going to go by every second line is like 1, 2, 3, 4. I'm going to spread it out a little bit. It might have to be the same on yours. It's not absolutely necessary, but it just makes it a little bit easier. And then I'm going to go up here 1, 2, 3, 4, negative 1. Okay. All right. If x is less than 0, we use the function f of x equals 1 over x. Now that was one of the ones on the sheet earlier, right? I don't think this is one you got memorized. You may not. Take a look at that sheet if you need to. But if I told you to plug in the number of stars, I told you to plug in 0. But if you plug in 0, what happens? What's 1 over 0? Undefined. We don't have it. I mean, you can put down undefined, but there will not be a point there. So I'm going to start at negative 1. Well, 1 divided by negative 1 is negative 1. Negative 2 gives me negative 1/2. Negative 3 gives me negative 1/3, and so on. So I'm going to start here. But we kind of run into a little bit of an issue. What happens in between negative 1 and 0? Okay? It doesn't just start there and go, if you plug in points, you get back points. Well, if you're looking at your sheet, you might know, but this is where sometimes you might have to, this isn't enough. I might have to plug in negative 1/2. Well, what's 1 divided by negative 1/2? Negative 2. So that's going to be, there's 1/2. And what about, I don't know, just negative 1/4? What's 1 divided by negative 1/4? It is negative 4. So if you look, that looks like this. Okay, that'll look like that. All right, take a look at the second piece. See if you can figure it out. If you need to do a table, which I highly recommend, I would do a table. Okay, so you got f of x. And for x is greater than or equal to 0, f of x equals negative 1/2 x squared plus 4. And plug in, you do need to plug in 0. All right, so when I'm graphing this or plotting this in, you plug in 0. 0 squared 0, you end up with 4. So you should have that point. All right, Cooper, what do you got after that? Did you plug in points?
Yeah.
Did you plug in 1?
Yep.
What'd you get?
3.5.
How about 2?
Oh, got it. 2 is 2.
And how about 3?
3 is negative 0.5.
Okay, so you're squaring 1, which is 1, negative 1/2 plus 4, good. Plug in 2, 2 squared is 4, negative 1/2 is negative 2 plus 2 is 2. So what we got here is 0, 4, 0, 4 right here. I got 1, 3.5. I got 2, 2, and what was 3, negative 1/2? It's an x squared, so it has to be a parabola. The negative in front makes it open down, right? Okay, so it starts up here. This has to be a solid dot. And it has to go through that. Okay. And so that should be enough to give you an idea for that one. All right. I would always, especially with x squared, because you don't know where the vertex is going to be. So it might be halfway in between there. So just be careful. All right. This last one is called the greatest integer function. Okay. Actually, let's graph it on our calculator first, and then we'll figure out why it looks the way it looks. Okay. And let me get my calculator out. And does anybody know where to find integer? Yeah. All right. It is. Hold on. Go to y equals, and as you see here, you have this notation here, like it's a bracket with a double bar there, and it says int or integer x. It is under to find that. Okay, you go to math. Okay, go to math. Go under the number menu, and it's number 5. Okay, number 5. And so you're going to hit that, and then just plug in x there. Just plug in x. All right, and then hit graph. Okay. This is also called as the step function because it looks like a set of steps. Okay, so integer x. Now I'm going to put it out here and I'm going to explain it. Let's see, I'm going to go a little bit backwards here. So when you graph this, now you can't see it exactly on there, but okay, it starts at 0, 0, and then there's really an open dot at 1, 0. Okay, and then at 1, it starts at 1, 1, and then there's an open dot at 2. Okay, 2, 1. And then looks like this, and then the same pattern. We'll go with the negatives. Now, so if for this function, so what is f of 3.2? Let me see if I can explain this. We want the greatest integer, and then less than or equal to the number we plug in. Well, what integer is less than 3.2? Okay, it would be 3. So that is when you go to 3.2, the answer is 3. And so what is f of 3.5? What is the integer, the biggest integer, but really just what's the next integer? Less than 3.5, it would be 3. Okay, and now you got to watch because you have a tendency to want to round. We're not rounding. What is the integer less than 3.8? 3. But now what happens is I get to 3.9, it's still 3. 3.99 is still 3, but what about f of 4? What is the integer less than or equal to 4? It is 4. So that's why it jumps. So basically it goes here, and then once it gets to 4, it jumps up to the next one here. Now you got to watch negatives because these are kind of, you got to watch that. What is the integer less than negative 2.5? Negative 3. It is negative 3, and if you look at the graph, negative 2.5, you go down there, it's at negative 3. Your tendency is you want to say negative 2, but you got to think it's got to be less than. So f of negative 0.5. What is less than, what integer is less than negative 1/2? It would be negative 1. Okay, so this is called a step function. Okay, now clearly it's similar to a piecewise function because it's made up of separate pieces. All right, so that's kind of it for 2.6. You got your library of functions, you got all those different ones. Piecewise functions, kind of a key one there. All right, only 5 problems?
Thank you.
Oh, see, you're getting soft. Getting soft. What are you doing, Morgan? I need to talk to you.
I'm playing with the integer thing. Well, like, it's like square and then times
It'll be zero.
it's just for
Hold again. Oh, I got
that's all. I tried there in this school.
Neither do I, but right now, I got 3 come. Yeah, I know.